Hi, this is a CBSE 12th Physics case study question. The passage is about a capacitor. The charges on the capacitor plates are Q and minus Q, and the potential is V1 and V2. The potential difference is V1 minus V2. The ratio Q by V is a constant denoted by C, which is the capacitance of the capacitor, which is independent of Q or V, but it depends upon the shape, size, and separation and the medium between the plates. When the parallel plate capacitor is charged, the electric field which is existing between the plates is represented by E naught, which is uniform. And when the dielectric slab is inserted between the plates, then the slab gets polarized, and the charge density on the plates is sigma, and the charge density on the dielectric slab due to polarization is sigma p. The sigma p is proportional to the electric field E naught. Due to the insertion of dielectric slab, the electric field changes, the capacitance changes, and also the energy changes. Like resistors, the capacitors can also be arranged in series and parallel. So the first question is, as shown in figure A, the area of the plates is A, the distance between the plates is D, and air is filled. And in second figure, the distance between the plates is increased to 2D, and the plate is shifted, second plate is shifted little above, such that the area of cross section becomes A by 2. So we have to find the new capacitance. Suppose C naught is the initial capacitance, so it will be given by A epsilon naught by D. And if C is the new capacitance, C will be A by 2 epsilon naught by 2D, or this is A epsilon naught by 4D, or this is C naught by 4. So the capacitance has reduced to 1/4. So the option is A. The second part, the second question is that a dielectric slab of thickness D1 is inserted between the plates. Slab, dielectric slab of thickness D1 and dielectric constant K between the plates having area of cross section A, and the distance between the plates is D, and given that D is greater than D1. So, and it is also given that sigma is the charge density on the plates and sigma P is the charge density on the slab. So we have to find what is the value of dielectric constant in terms of sigma and sigma P. So now here we can see in the diagram that the area of cross section of the plate is A, and D is the distance between the plates. D dash is the thickness of the dielectric slab. So the electric field E naught, if we represent the electric field between the plates before the insertion of the dielectric slab, then E naught is sigma by epsilon naught. And here, suppose this is sigma, this will be minus sigma. And when the dielectric slab is inserted, this side of the dielectric slab, the negative charges get accumulated, getting attracted to the positive plate, and on the right side, positive charges get accumulated. So an electric field is set up inside the dielectric slab, which is EP from right to left, whereas E naught is from left to right. So the net electric field gets reduced, and E will be E naught minus EP. EP, the electric field inside the slab, will be given by sigma P by epsilon naught, and E, The electric field due to the insertion of the dielectric slab will be given by sigma by K epsilon naught, where K is the dielectric constant of the dielectric slab. So substituting the value, we get sigma by epsilon naught is sigma by K epsilon naught is sigma by epsilon naught minus sigma P by epsilon naught. Epsilon naught gets cancelled. We get sigma by K is sigma minus sigma P, or K is equal to sigma by sigma minus sigma P. So the correct answer is B. Now the third one, an electric field E is established between the plates, and the charges on the plates are Qn minus Q. V is the volume of the space between the plates. So we have to find what is the energy. Energy is given by half C V square. V, the potential difference, we represent by Vp here, Vp square. C is given by A epsilon naught by D. Vp is electric field into D. We substitute the values, we get A epsilon naught by D into E square, D square. 1D cancels, we get 1 by 2. A D epsilon naught E square. A into D is volume, so we get half epsilon naught E square into V. So the correct option is C. Now the fourth question. There are three capacitors here, A, B, and M, connected in series, and the capacitance is C, and suppose the charge on them is Q. They are connected in parallel to N capacitor. Its capacitance is 2C, and the charge on it is Q dash. So we have to find what is Q dash by Q. Now to find Q dash, we should know what is the potential, because Q is given by CV, charge is, capacitance is 2C, and the potential difference is V. So Q dash is 2C V. Now to find the charge on capacitor A, we need to know what is the potential drop across the plates of the capacitor A. Now since they are connected in series, this potential drop V is equally distributed along the three plates. So we get the potential drop across A is V by 3. So the charge Q is C into V by 3, or Q dash by Q is 2CV by CV by 3, that is 6. So the correct option is D. Now the second subpart of the fourth question is that a dielectric slab of dielectric constant K and thickness D by 2 is inserted between the plates. Area of the plate is A, distance between the plates is D. C is the capacitance with the slab, and C naught without. So we have to find C by C naught. So C naught is A epsilon naught by D. And since the dielectric slab is partially filled, the formula for the capacitance is given by C naught 1 C naught 1 minus T by D 1 minus 1 by K. where T is the thickness of the dielectric slab, which is D by 2. So C is equal to C naught 1 minus D by 2 into D 1 minus 1 by K. So we get C is equal to C naught 1 minus half. When we open the bracket, we get 1 by 2K. Or this becomes C naught by half 1 plus 1 by K, or 2C naught K plus 1 by K, or C is equal to 2C naught 2C naught K by K plus 1, or C by C naught is 2K by K plus 1. So the correct option is B. Hope the problem is clear. If you want to see my further videos, please subscribe my channel and do share with your friends. Thank you.